So this is still 4, 4, 4, 5, graphing shifts, whatever. So we have our y equals a sine b. Gee, what do you think H and K stand for? Your horizontal and your vertical. Kathy? So basically what happens then, if you guys forgot, which you do, your H and your K are going to shift you. Excuse me. One thing that does happen in this book is that they will tend to hide that B value inside the parentheses. I think you may or may not have had one or two of those last year in Algebra 2 where you had to factor out a value that was in the parentheses to get the x minus h alone. This book will, from time to time, throw something in there where you'll have, -3 sine of 4x minus 4 pi plus 4, or something, I don't know, where you could factor the 4 out. You understand what I'm saying on that? You gotta pull that part out. What'll happen is sometimes this might just be 2 pi, which means you gotta pull out the 4, so then it becomes minus half pi. You guys remember seeing that once or twice last year? It's really about as goofy as any of this stuff gets. The rest of it is extremely straightforward from what you guys have done before. Okay? It's a matter of plotting your parent graph and then shifting it via your H's and your K's. Yeah.
Are we still going to period
I don't think we really, to be honest, I'll double check with Montana. I don't think, with shifted graphs, that's a lot. I think it just takes too much, it can tend to take a little too much time. I think with a shifted graph, we can start with one revolution, we might be like, we'll be all right. Excuse me. So let's look at an example of doing one of these. Let's just do that one. Y equals, what did I have? -3 sine 4x minus 2 pi plus 4. Excuse me. So it's a sine graph. We have to get the 4 out of the parentheses. Basically, whenever you have something in front of the value of x, that's the value you're going to factor out in parentheses every time, no matter what it is. Okay? It'll always work out that way. So we get y equals -3 sine of 4x minus a half, or I'll just write it as pi over 2 plus 4. And now you're at the point where you can go from there. How'd your surgery go? Oh. Postponed. Hopefully it didn't kick. But okay. The plague hit really hard.
It works.
It's easier to be here than it is not to be here. And then you guys will be behind. Sir.
Where would you need 4 then?
That's
your next step?
Yeah. Because now the next step is, now I know what to do for my A, B, H's, and K's, so I can start to distinguish amplitude, period, all that stuff. All that stuff. So your A value, gentlemen, -3, 4. What's my H? You did. And then what's K?
4.
Ah, it's positive. It's the same sign. So when you're in parentheses, that's when you do the opposite sign. Excuse me. And then if it's outside, it's the same. Now, your A value denotes what your amplitude would be, but in this case, since it's negative, is it going to go up or is it going to go down first? It's going to go down first. Okay. We still find our period for a sine function the same way. 2 pi over b. So my period will be at pi over 2. So I start by putting my parent function. Half of that is pi over 4. Half of that is pi over 8. And this is 3 pi over 8. Okay. It's going to go up and down to 3. That's your A. Again, just remember sine starts at the origin, goes to whatever your A value is, and then it goes back to 0, up to the opposite of A, and back to 0. Sir?
Would you like us to be parent function?
Yeah, I always thought that it's easier. It may take an extra second or two to plot the parent function, but it allows you to see where your ordered pairs are, and it's easier to get your breaks for where your shift goes. You know, when you have to schedule out your next period, the shifted period, if you will. One of the things that people that I've done in the past too. There's 5 of them, right? So this is the parent, and then the shift. You know it's going to be x plus pi over 2, and then k plus, y plus 4. A lot of people write out the ordered pairs and then just add the fractions to get your new list. Sometimes it's easier for people to see that to know where your next set of points are going to wind up going. It's totally up to you. I like to do it this way because it forces me to know that it's going to be pi over 2 and 4. 1/2 plus 1/8 would be 5/8. -3 plus 4 is 1. Pi over 4 and pi over 2 would be 3 pi over 4. 3 pi over 8, pi over 4, 7 pi over 8. 7, and then pi, and 4. It helps to figure out those next point values. Oh, let me do this. I got out of space. Hi.
Hey, what's on my way down?
Whoa. This is easy. Oh, towing your car, on the drugs. Bar. So our new endpoint would wind up being at pi. Middle is at 3 pi over 4. Seven. So now we're at pi over 2, 4. pi over 8, 1, 4, 7, and 4. And there's your new graph. I know you guys have seen that before. Okay. I think the goofiness usually lies in figuring out this part here. If you label it in terms of your x, y's, and just do your addition to them, or subtraction for whatever their h and k is, it tends to keep it a little bit cleaner. Okay? It just tends to keep it a little cleaner. Excuse me. Question on that at all? All right. Should we do a tangent? Let's go. What? Alright, let's see. There's a picture of your picture.
Oh, yeah.
I kind of caught that out of the corner of my eye when I was going through the paper.
You know, I didn't see it until I came to film the next day, and then coach was like, hey, did you, he's like, congrats. I was like, what? Front page of the paper.
That's pretty funny. Just a picture of your picture. My hero.
Yeah, it was in the back corner.
Now you need a picture of your picture of a picture on a shirt.
So I take a picture of that.
And then take a picture of the shirt.
Yes. You take a picture of you looking at the picture of your picture,
Wearing the shirt.
wearing the shirt of the picture, looking at the picture.
That gives another shirt made out of
So if I make you that shirt, you'll wear it.
A picture of you looking at the picture of your picture?
Right.
Sure. I will wear that.
Alright.
Yes. All right, let's do a tangent. Excuse me. Do the same thing. Walk it through the tangent one. Okay. I put one up right off the bat that had that b value snuck into the parentheses, so we gotta take that 2 out and divide both parts out by 2 and multiply it by half. So you rewrite, you get -4 tangent 2x plus pi over 8. And then label your A, B, H's, and K's. So A is -4, B 2, H negative pi over 8, K -3. Okay. Period for a tangent graph is pi over b. Which now places our asymptotes. The period's at pi over 2 prior to the shift where your asymptote's going to be at. Pi over 4 plus minus pi over 4. Okay. So that's where we start. Start the graph at your origin. So it's negative pi over 4. Excuse me, pi over 4. Halfway spots. Just multiply your asymptotes by a half and it'll give you your points. A value's at -4. So if the A value is negative, what direction is tangent going? Very good. Moving down to the right. Points of inflection occur at the A values. And so you've got negative pi over 8 and positive 4, 0, 0, and pi over 8, 4. This graph has got to be shifted negative pi over 8. So which way is that moving? Going to the left. Okay. So if you're asymptotes, we're at x equals negative pi over 4 and x equals pi over 4. Your shift, move this over here. It's going to be x minus pi over 8 and y minus 3. You can set those right in that same column, if you will, to find your new breakpoints a little bit cleaner. And then trying to do all the shift stuff first via the asymptotes. Negative 1/8 minus another 8 would be negative 2/8, otherwise known as negative pi over 4 and 1. Yeah, I can do this one. I can do this one too. Let's just go negative 7. And now I go to the asymptotes, same deal. List them, figure out which way they're going. If you're at negative pi over 8, you're at negative pi over 4, you're subtracting another 8, you'll be at negative 3/8. A lot of these fractions are going to be stuff to be able to change in your head without so much of a hassle. 1/4 is 2/8. Just go from there. And this would be at pi over 8. So it's just a matter now of relabeling. Put in another asymptote. Tangent graphs sometimes is better if you've got two colors, a pen or and a pencil, or two-color pen or two-color pencils. Negative pi over 8, negative 3. 0, negative 7. And pi over 4, 1. And there you go. Yay. So let's do this. Let's do. So I know which ones to do. Excuse me. So in 4, 5, we'll do numbers. Let's see. 40.
Let's call it one.
All right, so in 4, 5, we'll do 48 and 53. Those are cosines. 54 and 55, they're written as cosines, but I want you to do sine, because there aren't any sine shifted ones. Does that make sense? So this is on 329. Okay. So I've got two cosine shifts, two sine shifts, even though they're labeled cosines, rewrite them as sine. And then we'll do a couple tangent ones also. Then we'll get into the all the weird ones tomorrow. So we'll do, let's see. 4, 6. All right, let's do those for that. So I'll give you 6 of them. 2 of each. All right. Oh, no, 48, 53, and then 54, 55. Just change 54, 55 to sign. It says co-sign on the props. I really, it's kind of surprised they didn't have that many sign shifted ones. So.
I'll fix it for you, Mark.
What time?